Hello, everyone, and welcome to the DOK Day at KubeCon North America 2022. I'm Tapan Halani, the DOK Explorers intern and a freelance cloud solutions architect based in India, and it's my absolute pleasure to be presenting before you guys here at KubeCon. Well, today my pleasure is doubled because as we tech enthusiasts are celebrating open source here at KubeCon, we, the people of India, are celebrating Diwali, the festival of lights all around the world to celebrate peace, hope, and prosperity. So, from all of us at DOK community, a very happy Diwali to all of you. May your KubeCon experiences be as phenomenal as the illuminated night of Diwali. Today, I'll be talking about a very interesting topic, our first project as DOK Explorers intern, something that is considered to be a day two operations task, yet it's absolutely necessary for any production ready Kubernetes native architecture. Today, I'll be talking about backups in Kubernetes. How has the deployment of stateful applications changed? Well, this slide will give a rough idea where on the left side, we see a traditional virtual machine based, not highly available data application. While on the right hand side, we see a Kubernetes cluster with two stateful applications, one database and one cache, designed in a highly available way. The single biggest difference here is that in traditional way, the application process, the data application is running on one particular server, which is why the disk volume also needs to be attached to only that server. Basically, there is a static mapping between application, the virtual machine, and the data disk. Whereas with containers, Kubernetes cluster topology becomes very dynamic. The pod can be scheduled on any worker node in the cluster, which means the data disk of the application pod also needs to travel with the pod. With this difference in the mind, let's start jotting down the differences in the next slide and also take the right-hand side diagram with us. So the first difference, dynamic topology, which basically calls for a backup solution that can discover where the stateful application pods are running and back up their data volumes. Different type of components. Well, to run an application in Kubernetes, we submit a set of deployment manifests to the Kubernetes control plane, based on which it creates Kubernetes resources for the application, like stateful set, pods, services, service accounts, hosts, and volumes. The application deployment is considered successful only when all of these components are in a ready or running state. Therefore, a full, easy to restore backup of any application in Kubernetes needs a backup of all these underlying Kubernetes resources. Failures from misconfiguration by developers. Well, contrary to the traditional way of handling infrastructure, Kubernetes has been helping teams become agile by adopting two key DevOps concepts. First, removing the barrier between developers and operations, basically making the application developers the owners of the respective infrastructure. And second, the shift left approach, which basically means shifting the testing, quality, and performance evaluation phases early in the software development lifecycle away from our precious production deployments. But misconfigurations can still happen, which might cause data loss or corruption, or render a particular part of the cluster in a failed state. Again, we need a solution that is Kubernetes native, which can reliably back up all the required Kubernetes cluster components without the need of manual intervention or any change from application developers or our operations team. Application aware data backups. Well, in other words, it's also called application consistent data backups. They not only capture disk snapshots at one point in time, but also flush pending IO transactions and in-memory data to disks before snapshotting, basically providing a holistic backup capable of faster and reliable restores. That's good, but how is this different in Kubernetes? Well, if you see the diagram of our highly available database, if we see the diagram on the left side, our highly available database and cache applications, they are deployed as 3 replica stateful sets in the cluster with pods running on different nodes. A truly application consistent backup needs to capture the state of all the pods at the same time, which requires the solution to not only discover but also access the application and its state for a backup. Security. Well, all the above points reiterates the need for a Kubernetes native backup solution which can discover and access multiple resources in the cluster. This ability in itself can pose a security challenge. Backup solutions must have only enough permissions to securely access application and data components, create a viable backup, and securely store the backup with proper access and encryption settings. The access to the backups and ability to restore must also be tightened using Kubernetes and Cloud IAM and RBAC to prevent malicious access to data and backups. So now that we know the differences between a traditional and Kubernetes native backups, let's move to the different components which should be a part of the Kubernetes backup. What we see here is a functional view of a Kubernetes backup. We see here stateless Kubernetes resources, which can be backed up as live manifests. Stateful Kubernetes resources like persistent volume, which basically represent a cloud storage, such as hard disks, backed up as CSI volume snapshots. But there's an important third component. What if the data store used by the applications in Kubernetes is running outside of the Kubernetes? For example, an AWS RDS instance or an Azure cache for Redis cluster. Though these are fully managed services from cloud vendors with their own tooling for defining backups and restore processes, they become a vital part of Kubernetes, or rather, cloud native backup strategy to provide a holistic and application consistent cloud native backup and restore process. Let's dive into the existing solutions in the market that provides us Kubernetes native backup and restores. Many of these you can also find on the VOK landscape page. This list is definitely a non-exhaustive list. These are the solutions that we VOK Explorer interns have had the chance of going through while our research project. For today, as we move towards the end of the presentation, I'll take up Cloud Casa as one of the solutions to describe how it solves the Kubernetes native backup and restore problem. So backup as a service with Cloud Casa. With Cloud Casa, you can protect all of your Kubernetes clusters, cloud application data, manage cloud storage. You can have unlimited container storage snapshots, and you don't have to pay any upfront costs, or you don't need to manage any servers or install any servers. Well, that's a pretty good set of features for a cloud native backup as a service solution. So as we move towards the end of the presentation, I would like to thank everybody to take out the time to listen to us, and a big shout out to the DOK Explorer interns, the team without which this project wouldn't have been as fun as it had been. And yeah, we are looking for more interns, more like-minded people to always join us to get into this, to get to know more about the cloud native, Kubernetes native problems, and to discuss about such solutions. And a very special thanks to the 3 mentors in the DOK community, without which our project wouldn't have been this fun or this smooth. Abhijit, Bart, and Sebastian, thank you for helping us out with Cloud Casa, with data on Kubernetes. It has been a phenomenal experience, and hope you guys have enjoyed the presentation. Hope you guys enjoy the rest of your KubeCon. This is Tapan Halani signing off.